March 6, 1944. 1,347 hours, 28,000 feet above Berlin. Oberleutnant Franz Stigler of Jagdgeschwader 26 checked his fuel gauge and allowed himself a moment of satisfaction. The American bomber formation below him, Boeing B-17 seconds, struggling home after attacking ball-bearing factories, was now beyond the range of enemy fighter protection. Standard doctrine held that American escort fighters possessed a combat radius of approximately 400 miles. Berlin lay 570 miles from England. For the next 90 minutes of the bomber's return flight, they would be vulnerable. Stigler's Focke-Wulf 190 had climbed to altitude specifically to intercept these crippled bombers once their escorts turned back. He had executed this tactic dozens of times since late 1942. The Americans would send their bombers deep into Germany, protected by P-47 Thunderbolts or P-38 Lightnings. Those escorts would accompany the bombers to the limit of their range, then turn back. German fighters, conserving fuel by avoiding early engagement, would wait for this moment. The defenseless bombers, already damaged by flak, would be easy prey. Stigler rolled his fighter and dove toward a straggling B-17 trailing smoke from its No. 3 engine. He was committed to his attack run, 500 yards and closing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. When he saw something that violated every assumption upon which Luftwaffe fighter doctrine was constructed. Diving toward him from the sun came 3 American P-51 Mustangs, their distinctive profiles unmistakable, their presence over Berlin impossible. They shouldn't have had enough fuel. They couldn't have enough fuel. The mathematics were simple and absolute. No single-engine fighter possessed the range to escort bombers from England to Berlin and return. Stigler broke hard right, abandoning his attack, his mind struggling to reconcile what his eyes showed him with what he knew to be technically impossible. In that moment, watching those silver Mustangs position themselves between him and the bombers, Stigler witnessed the death of German air defense doctrine and the beginning of the end for the Luftwaffe. The P-51 Mustang's presence over Berlin in March 1944 represented more than tactical surprise. It marked the culmination of engineering innovation, industrial mobilization, and strategic vision that would fundamentally alter the air war over Europe. The story of how those fighters came to fly 1,650 miles into Germany and return begins not with American engineering brilliance, but with American failure. In 1940, as the Battle of Britain raged, the British Purchasing Commission desperately needed fighter aircraft. American P-40 Warhawks were available but considered inadequate for the European theatre. The Commission approached North American Aviation with an order for P-42s to be built under license from Curtiss Wright, James H. Kindleberger, North American's president, made a bold counter-proposal. Instead of building obsolete P-42s, his company would design and build an entirely new fighter, incorporating lessons from European combat. The British, skeptical but desperate, agreed on one condition: the prototype must fly within 120 days. North American Aviation delivered the NA-73X prototype in 117 days. The aircraft that first flew on October 26, 1940, designated XP-51, demonstrated exceptional aerodynamic efficiency. Its laminar flow wing, designed by Edgar Schmood, chief designer, generated less drag than conventional airfoils. The aircraft was fast, reaching 390 miles per hour in level flight with the Allison V-1710 engine. But the Allison engine's single-stage supercharger performed poorly above 15,000 feet, precisely where bomber escort combat occurred. The RAF, which began receiving Mustang Mark-Is in November 1941, relegated them to low-altitude reconnaissance and ground attack roles. The aircraft was superb below 10,000 feet and mediocre above 20,000 feet. The transformation came through British initiative. In April 1942, Ronald Harker, test pilot for Rolls-Royce, flew a Mustang at the Royal Aircraft Establishment at Farnborough. Harker immediately recognized that the airframe's aerodynamic excellence was being wasted on an inadequate engine. He recommended fitting the aircraft with the Rolls-Royce Merlin 61, a two-stage, two-speed supercharged engine that powered the Spitfire Mark 9. The Merlin engine transformed the Mustang from an excellent low-altitude fighter into arguably the finest all-around fighter aircraft of World War II. The combination of the P-51's efficient airframe with the Merlin's high-altitude performance created an aircraft with exceptional range, high-altitude capability, and combat effectiveness. The first Merlin-powered Mustangs, designated Mustang X by the British, flew in October 1942. Performance improvements were dramatic. Maximum speed increased to 441 miles per hour at 25,000 feet. Service ceiling rose from 30,000 feet to 41,900 feet. Rate of climb nearly doubled. But most significantly for the Strategic Air Campaign, fuel consumption per mile improved dramatically at high altitude. The Merlin engine's efficiency at 25,000 feet, combined with the airframe's low drag, gave the aircraft unprecedented range for a single-engine fighter. The United States Army Air Forces, initially skeptical of the British-designed Mustang, began serious procurement when Merlin-powered performance data arrived in Washington. The critical decision came from Major Thomas Hitchcock, Assistant Air Attaché in London and a World War I fighter ace. Hitchcock recognized immediately that a long-range escort fighter could be built around the Merlin Mustang. In September 1942, Hitchcock wrote directly to Major General Carl Spaatz, commanding the 8th Air Force, advocating for rapid procurement of Merlin-powered Mustangs. His letter stated that the aircraft represented the only current design capable of escorting bombers to targets deep in Germany. The United States lacked domestic production of Merlin engines, but Packard Motor Company had begun producing them under license in 1941 for British Spitfires and Hurricanes. The Army Air Forces contracted with North American Aviation for production of the P-51B, powered by the Packard V1 6503, the American-built Merlin. The contract, signed in June 1943, called for immediate mass production. North American's Inglewood, California plant would build the P-51B. A new factory in Dallas, Texas would produce the identical P-51C. Production began while the aircraft was still being tested, a calculated risk that German bomber losses made necessary. The first production P-51Bs were delivered to the 8th Air Force in November 1943. Initial deployment focused on familiarization and tactical development. Pilots transitioning from P-47 Thunderbolts or P-38 Lightnings required training on the Mustang's different handling characteristics and longer range capabilities. But even with internal fuel only, the P-51B could not reach Berlin. The aircraft carried 184 gallons internally, later increased to 269 gallons with fuselage tank installation. This provided a combat radius of approximately 550 miles, with normal reserves. Berlin required 825 miles of combat radius. The solution was external fuel tanks, disposable metal tanks carried under the wings that could be jettisoned when empty or when combat began. Drop tanks were not a new concept. German and Japanese aircraft had used them since the 1930s, but American drop tank development had been neglected during the interwar period. The 8th Air Force's immediate need for range extension triggered crash programs to design, test, and produce drop tanks in quantity. Multiple designs emerged simultaneously: a 75-gallon tank, a 108-gallon tank, and eventually a 110-gallon tank that became standard. Each design required testing to ensure it didn't affect aircraft handling or present hazards during jettison. The engineering challenges were substantial. Tanks had to withstand air pressure changes from ground level to 30,000 feet. They required self-sealing properties in case of battle damage. The attachment mechanism had to be reliable yet allow instant jettison. Fuel feed systems had to function at extreme altitude and temperature while preventing airlocks. British engineers at the Royal Aircraft Establishment developed a paper composition drop tank, essentially layered paper treated with resin, that was cheap to produce and worked adequately at low altitude. But paper tanks tended to fail at high altitude where temperatures dropped to -50 degrees Fahrenheit and pressure differentials were extreme. American engineers settled on pressed steel tanks with internal baffles to prevent fuel sloshing. These were more expensive but functionally superior. Each tank cost approximately $18 to manufacture and weighed 42 pounds empty. Filled with 110 gallons of 150-octane fuel, total weight approached 900 pounds. Installing 2 fully loaded drop tanks under a P-51's wings added over 1,800 pounds to takeoff weight. This required longer takeoff runs, affected initial climb rate, and reduced maneuverability until the tanks were empty or jettisoned. Pilots learned to fly the first hour of a mission carefully, conserving altitude and avoiding combat until the drop tanks were consumed. The tactical employment of drop tanks now required precise planning. Fuel management became a critical skill. Pilots had to monitor consumption rates, calculate remaining range, and decide when to jettison external tanks. Jettisoning too early meant shorter range. Keeping tanks too long meant reduced combat effectiveness, if intercepted. Standard procedure developed through trial and error established protocols that maximized range while maintaining combat capability. Pilots would take off with 2 full drop tanks and full internal fuel. They would climb to altitude using internal fuel only, preserving drop tank fuel for cruise. Once at combat altitude, typically 25,000 to 30,000 feet, they would switch to drop tanks. The most efficient cruise speed for maximum range was approximately 300 miles per hour indicated airspeed at 25,000 feet. This represented a compromise between fuel consumption and time over target. Faster speeds consumed fuel exponentially. Slower speeds meant longer exposure to German fighters and increased vulnerability. As the Escort approached the combat area, typically 100 miles from the target, pilots would attempt to empty drop tanks completely. The moment combat began or enemy fighters appeared, external tanks were immediately jettisoned to restore full maneuverability. The P-51 carried ammunition for approximately 24 seconds of continuous fire from its 650 caliber machine guns. Combat rarely lasted more than a few minutes before German fighters broke off or were shot down. After combat, the long flight home began with only internal fuel remaining. Pilots calculated return range, assuming no further combat and maintaining optimum fuel conservation speed. The margin for error was minimal. Unexpected headwinds, navigation errors, or additional combat could leave aircraft with insufficient fuel to reach England. The mathematics of range were unforgiving. With internal fuel and 2 110-gallon drop tanks, total fuel capacity reached 489 gallons. The Merlin engine at cruise settings consumed approximately 70 gallons per hour. This provided 6 hours and 50 minutes of total flying time. But combat operations required reserves. Standard procedure mandated landing with at least 30 gallons remaining. Combat consumed fuel at accelerated rates. Climbing to altitude after takeoff used substantial fuel. The result was an effective combat radius of approximately 825 miles, sufficient to reach Berlin with acceptable margins. The first P-51 escort mission to Berlin occurred on March 4, 1944. The 354th Fighter Group, operating from RAF Boxted, provided escort for bombers attacking Berlin. Weather forced mission recall, but 2 groups of Mustangs reached the German capital, marking the first time single-engine American fighters had appeared over Berlin. March 6, 1944 brought the first successful heavy bomber raid on Berlin with full P-51 escort throughout the mission. The 8th Air Force dispatched 730 bombers, protected by 801 fighters, including 668 P-51 Mustangs from multiple fighter groups. German fighter controllers, observing the raid develop, predicted the American escorts would turn back at the German border or slightly beyond. Intelligence briefings had established American fighter range at approximately 400 to 500 miles combat radius. Berlin was beyond this range. Luftwaffe fighters assembled to intercept the bombers during their unescorted return flight. When P-51 seconds appeared over Berlin, staying with the bombers throughout the attack and escort on the return flight, German fighter doctrine collapsed. Luftwaffe tactics since 1943 had exploited the range limitations of P-47 seconds and P-38 seconds. German fighters would avoid engagement during the inbound escort phase, wait for escorts to depart, then attack the bombers. This doctrine worked. Bomber losses on deep penetration raids regularly exceeded 5%, occasionally reaching 10% or higher. At such loss rates, bomber crews faced statistical certainty of being shot down before completing their required 25 mission tour. The appearance of P-51 seconds over Berlin invalidated this entire tactical approach. German fighter pilots, trained to wait for the escorts to leave, found the escorts weren't leaving. Controllers directing fighters to intercept bombers on the return leg found American fighters still present, still aggressive, still at full combat capability despite flying from England. Prisoner interrogations conducted after the March 6 mission captured German incomprehension. One Luftwaffe pilot, Oberfeldwebel Werner Schroer of JG-3, shot down near Magdeburg, told American intelligence officers that he had been briefed the American escorts would turn back before Berlin. When he engaged what he believed were unescorted bombers near Hanover, 60 miles west of Berlin, he was immediately attacked by 3 P-51 seconds. Schroer stated he could not understand how American fighters could be over Germany, hundreds of miles from England, and still possess enough fuel for combat. He had assumed they must be operating from forward bases in Belgium or France, though he knew Allied forces did not yet control airfields that far east. When informed the P-51 seconds had flown from England, Schroer reportedly sat in silence for several minutes before stating, "Then we have already lost the war. If your fighters can reach Berlin and engage us over our own territory, we cannot defend Germany. Our fighters must conserve fuel. Your fighters apparently have fuel without limit." This response, documented in interrogation reports, illustrated the psychological impact more than the tactical consequences. German pilots understood immediately that American fighters with sufficient range to escort bombers throughout. Deep penetration missions fundamentally altered the strategic balance. The Luftwaffe had built its defense of Germany on the assumption that bomber formations would be vulnerable during portions of their missions. Fighters with unlimited range, or what appeared to be unlimited range, eliminated that vulnerability. Every target in Germany could now be attacked by bombers with full fighter protection from England to target and return. The March 6 mission cost the 8th Air Force 69 bombers, lost to all causes, and 11 fighters. German losses exceeded 160 aircraft destroyed, approximately 80 shot down by American fighters, and the remainder by bombers' defensive fire or operational accidents. The exchange ratio favored the Americans dramatically. More significantly, Luftwaffe fighters had failed to inflict prohibitive losses on the bombers, despite concentrating their defenses around Berlin. The Americans had demonstrated they could strike the German capital with acceptable losses, while the Luftwaffe defending its own capital had suffered devastating attrition. German fighter commanders recognized the implications. General der Jagdflieger Adolf Galland, commander of German fighter forces, later wrote that the appearance of long-range American escort fighters over Germany marked the definitive turning point in the air war. From March 1944 forward, German fighters could no longer dictate the terms of engagement. Galland's assessment noted that Luftwaffe fighters had previously been able to attack at times and locations of their choosing, exploiting gaps in escort coverage. With P-51 seconds capable of accompanying bombers throughout their missions, German fighters faced a choice between engaging under unfavorable conditions or ceding air superiority entirely. Either option was strategically untenable. Engaging meant accepting high losses against numerically superior and tactically advantaged American fighters. Not engaging meant allowing bombers to systematically destroy Germany's industrial capacity without opposition. Galland concluded that by April 1944, the Luftwaffe had effectively lost air superiority over German territory, despite operating over its own homeland with interior lines of communication. The production statistics behind the P-51 program revealed American industrial capacity operating at full capability. North American Aviation's Inglewood plant produced P-51Bs beginning in May 1943, reaching peak production of 430 aircraft per month by April 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Dallas plant added 350 aircraft monthly by mid-1944. Combined P-51 production from all variants totaled 15,686 aircraft delivered between 1942 and 1945. This included 7,956 P-51Ds, the definitive version with bubble canopy and improved armament that entered service in summer 1944. Peak monthly production reached 942 aircraft in March 1945. These numbers represented complete aircraft ready for combat, including engines, armament, radios, and all systems. Each P-51 contained approximately 26,000 individual parts manufactured to precise specifications and assembled by skilled workers. The Packard Motor Company's Merlin production paralleled aircraft production. Packard manufactured 55,000 Merlin engines during the war, including engines for P-51 seconds, Lancaster bombers delivered to Britain under Lend-Lease, and other aircraft. Peak production reached 3,000 engines monthly, each requiring 250 hours of machining and assembly. The drop tank production program involved dozens of manufacturers. By summer 1944, American factories were producing 100,000 drop tanks monthly, treating them as expendable ammunition rather than reusable equipment. Each mission over Germany required approximately 1,000 drop tanks. Most were jettisoned over Europe, though some pilots managed to land with empty tanks attached for reuse. The training pipeline for P-51 pilots represented another massive undertaking. The Army Air Forces established dedicated training programs to transition fighter pilots to the Mustang. Training emphasized long-range navigation, fuel management, and formation flying. The syllabus required 80 hours of flight time in the P-51 before combat deployment. By early 1944, training schools were graduating approximately 250 P-51 pilots monthly. These pilots replaced combat losses and equipped newly formed fighter groups. The 8th Air Force ultimately fielded 15 fighter groups equipped with P-51 seconds, each group containing approximately 75 aircraft and 100 pilots. The logistical support structure required to maintain P-51 operations from England involved thousands of personnel. Each fighter group required approximately 100 maintenance personnel, including mechanics, armourers, and specialists in engines, hydraulics, and electrical systems. Additionally, supply chains delivered spare parts, ammunition, fuel, and drop tanks. The 8th Air Force consumed approximately 10,000 gallons of 150-octane aviation fuel daily for each fighter group. Ammunition requirements reached 3 million rounds of 50-caliber ammunition monthly for the fighter force. These supplies crossed the Atlantic by convoy, were distributed to airfields across England, and were maintained in sufficient stocks to sustain continuous operations. Weather often dictated operations. The English climate provided flyable conditions approximately 180 days per year. On non-flying days, maintenance crews performed inspections, repaired battle damage, and conducted engine changes. Each Merlin engine required replacement or major overhaul after approximately 200 hours of operation. Combat conditions reduced engine life significantly. The organizational structure supporting escort missions required precise coordination. Mission planning began 24 hours before takeoff. Intelligence officers briefed pilots on target information, expected enemy fighter concentrations, flak positions, and weather conditions. Navigation officers calculated courses, checkpoint timings, and fuel requirements. Each mission required multiple groups of fighters to provide continuous coverage. Some groups would escort the bombers to the target, while other groups provided withdrawal support. Fighter sweeps ahead of the bomber stream attempted to clear German fighters before they could intercept. The coordination involved hundreds of aircraft, maintaining strict time schedules over distances exceeding 1,000 miles. Radio discipline was critical. Fighters maintained radio silence except for combat calls. German radio monitoring stations tracked Allied formations by radio transmissions, allowing fighter controllers to position interceptors. Excessive radio communication provided intelligence to the enemy while cluttering frequencies needed for urgent tactical information. The typical escort mission profile followed established patterns refined through experience. Fighters would take off from their English bases approximately 30 minutes before the bombers departed. They would climb to altitude over England, forming up into groups and then larger formations. As bombers departed the English coast, fighters would join them, positioning themselves above and to the flanks. The bomber stream typically stretched for miles, multiple groups flying in combat box formations designed to maximize defensive firepower. Fighter groups divided responsibilities, with some staying close to the bombers while others flew higher and ahead, ready to intercept German fighters before they reached attack position. German fighter tactics evolved in response to P-51 escorts. Initially, Luftwaffe fighters attempted to break through the screen of escorts to attack bombers. This proved costly. American fighter pilots, flying aircraft with performance equal or superior to German fighters, defended aggressively. The P-51's combination of speed, altitude performance, and firepower made it a formidable opponent. German pilots increasingly found themselves outnumbered. The 8th Air Force regularly dispatched 600 to 800 fighters on major missions. The Luftwaffe, even when committing maximum forces, rarely fielded more than 400 fighters simultaneously. American numerical superiority, combined with tactical advantages of the escort role, created situations where German fighters faced multiple enemies in every engagement. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.